My name is John Tiskowski, and I'm the Vice President of Customer Success at SmartPM. I want to thank you all for joining today's webinar entitled Delay Analysis in Less Than an Hour. Today's session will be directed by Mr. Mike Pink, founder and CEO of SmartPM, a schedule analytics and risk management tool for the construction industry. I hope everyone is ready to witness the power of data analytics and automation applied to performing a delay analysis. So without further delay, I'll turn it over to Mr. Mike Pink. So Mike, let's get it going.
Hi, everybody. How you doing today? This is Michael Pink coming at you from Atlanta, Georgia. I'm the founder and CEO of SmartPM Technologies. Prior to forming SmartPM Technologies, I've worked as a delay analyst on a lot of projects all over the world. Worked for companies like Deloitte, KPMG, and FTI. I am a certified PSP, which is a planning and scheduling professional from the AACE group. I'm also an industrial engineer from Georgia Tech, that is, and I have an MBA. So I've got a lot of experience in the delay analysis field, which we'll talk about in a little bit. And I'm very excited to show you guys the system that we've created to run some of the most accurate and intense delay analysis I've ever seen, which we'll jump into right about now. Before I get into that, I want to walk through what are we going to do today. Obviously, we're going to have an introduction, which we've already done. And then I'm going to load some schedules into SmartPM. I'm going to show you that tool. I'm going to load those schedules live. And we're going to run a delay analysis. Takes a little bit of time to run these delay analysis, a few minutes. So in that time frame, while it goes off into the cloud and runs the analysis, while we wait, we're going to talk a little bit about delay analysis best practices, at which point after about 5 or 10 minutes, or however long it takes me to talk about this stuff, we're going to jump right back into the product, and I'm going to walk you through the analysis. In that point, we're probably going to make some refinements to the data, rerun the analysis to get a little bit closer to an answer. And I'll talk to you a little bit about that as I go through it. And at the end, we'll review some of the findings, have a few closing comments, and hopefully move on with a very exciting understanding of delay analysis done by a computer. So I'm going to start out by logging in and opening up our system. Over to the right, you'll see a second screen. On the left-hand side is our presentation. On the right-hand side is our tool. It's browser-based. So you log in online. You got to have an internet connection. That's how we communicate in the cloud and bring the data to the place where the cloud can read it. The first thing I'm going to do is add a new project. I'm going to give it a name. We're just going to call this Delay in an Hour. We have to load a baseline schedule. We can import XERs, we can import MPPs, which are Microsoft projects, or we can actually build and manage schedules in SmartPM and analyze delay in real time. For purposes of today, we're going to use an XER. This is a project we ran several years ago, actually manually. So I'll show you today us run it via SmartPM. The next piece of information I need to put in here is a zip code. Zip code is to know where the project is so that weather data can be graphed every day from NOAA, and we can understand where that weather is. So we need to put that postal code in. So anyway, I've put that first data in. Now I've got to go find the baseline schedule, which is on my computer. I'm going to go ahead and grab this baseline schedule, and I'm going to import it. And you will see this thing import, and it will create an instance on our program. And right now, we have now an instance. This is called Delay in an Hour. This is our program dashboard. We haven't run any analytics yet. I'm going to open this project up to our project dashboard. I hope you can see it okay. And I'm going to start uploading the additional schedules right now. So next thing I'm going to load is the second update, or the first update. This will sit right on top of the original file, and now you'll see this list forming. We've got our baseline, we've got our second update, and I'm going to actually go ahead and add our third update. What we have here is about 16 schedules spread out over a 1.5-year period. I'm going to actually jump back into the slides over here while we continue to load this, and I'm going to talk to you a little bit about delay analysis and what are the steps. So I've got my buddy Billy here filling filling out and loading these schedules here while I talk to you a little bit about delay analysis. The first thing to understand is that there's really 5 steps to analyzing delay. And they need to happen on every delay analysis. And if anything's missing from here, then you haven't actually done a full delay analysis. But usually the first step is to make sure you're getting schedules of good quality. And when I say quality, I mean they were built well. They were built in a manner that included the necessary activities to the necessary detail, the necessary logic to make the schedule reactive so that it's actually a CPM schedule that's functional with an accurate critical path. We need to make sure that that's there. If that's not there, then our analytics are going to be off because of erroneous critical paths, schedules that aren't, actually reactive enough and can become easily compressed. Not enough detail is usually an issue. So we need to look at that. And usually when you get a bunch of schedules, you got to look at the baseline, and then you've got to watch it over time and make sure that that integrity that was in the baseline is maintained at every update. And that starts to get us into looking at modifications from update to update. One of the things that we all know and love in construction is that projects change. Delays happen, things change, mitigation strategies need to be implemented, and therefore, your baseline morphs into something else. So when doing a delay analysis, we need to look at every single update. I know that some people on this line may be wondering about what types of analyses are we talking about. We're talking about every kind of analyses. There's as planned as built, there's windows analysis, there's collapsed as built. All these things still require that every schedule that was utilized on a project is understood, and every change that was made over time is understood, because that will play into what the decisions that you make on which analysis is most worth it or most worth our time as analysts to perform. Alongside of that modification check, we need to always be looking at feasibility. One of the biggest challenges in construction is that decisions are made without analyzing the data beforehand. For instance, projects become delayed and end dates don't change. The reason that happens is because logic or durations were changed from update to update, meaning mitigation strategies were built in. This happens frequently in construction, and it needs to be understood. The decision-making processes need to be understood from update to update, because this plays into feasibility. And if there's any hint of overconfidence or manipulation built into the process, you need to start questioning the integrity of that data and determine if we need to not use that data as purposes of the analysis. So now when you get handed all these schedules and you go through that process, you need to start documenting your thoughts so that you can return to them after you run the delay analysis. But those are the first real things that you need to do in a delay analysis, just to make sure that you're working with data that's decent to run the analysis. And then after you get through all that information, then you can start running your delay analysis. You can do different kinds. For purposes of today, my opinion of the matter is you should be using as many contemporaneous schedules as you can. You just have to verify that they were, actually reflective of reality and or had accurate data behind them. And that's what we do with these first 3 pieces here. And then we run into the delay analysis. After that, you study your results and you determine, based on the data that I've placed in here, is there anything that's popping up that just seems out of place or odd? And then you can start refining the analysis. And refining the analysis also entails meeting with whoever was involved with the job, running through the explanation of what we found to date with this analysis, and then making any sort of modifications to the approach if things seem a little bit out of whack. And that's what I call refining the analysis. And that actually takes time as well. One thing that I will tell you right now is that we are not talking about expert reports right now. We're talking about the analysis portion of the work. We're not talking about going through documents and understanding causation and responsibility for the delays that we identify. We're talking about the first step in every delay analysis is analyzing the data and then understanding what the delays were based on the data. Far too many, I would say, analysts out there start on the other end of the equation and are told what the delays are and then try to figure out a way to make the schedule say that. I'm actually talking about the real approach that we need to do and look at the data first, let the data tell you, give you some direction on identifying delay, and then you go into understanding why those happen once you believe that you've gotten to a place where the analysis is accurate. I'm going to pop over to another slide real quick. The case study that we're looking at today was a $20 million project with a $2+ million delay claim. There was a total of 16 schedules that were submitted over 18 months. There was 6+ months of delay. The project was supposed to get done in March of 2016, got done this September 2016. And right here is really the hours that we built as a consultancy to analyzing this information. Obviously, we started out with looking at quality and the updates, and this was about a week and a half, going through it with a fine-tooth comb, using things like Claim Digger, Acumen Fuse. You know, this is how many hours it takes even with those tools. Next thing we need to do is once we go through that and get a lay of the land on quality and the updates and the changes, we need to make an assessment as analysts whether or not these schedules are getting to a point where they're a little aggressive, a little too compressed, and determine if there's a point in time where we need to stop relying on the schedule data and really start understanding the as-built data with the latest acceptable schedule. And then that's the point where we start to run a Windows analysis. And back in the day when I did this manually, I would pull out a bunch of graph paper and start drawing calendars and stuff and get my pencil and ruler out and start summarizing the schedule and starting to understand how the logic in this thing really works from update to update to update. And then I'd create my as planned schedule in summary version so that I could understand it. And I'd start taking as-built data and comparing against that to better understand, you know, where was the critical path and in each period how much delay was occurring. And these things take, you know, this is not something that's very easily done in a short amount of time. Week and a half is about the amount of time it took on this one to go through about 16 schedules, and that's on a smaller project. And after that, you know, we ran our first pass at the analysis. Sorry about that. After that, we ran our first pass in the analysis, talked to the client, needed to do some refining work, needed to update some as-built data. Things were pointed out in there that may not have been accurate in the actual schedules. And then the last thing we needed to do after that is we needed to do our graphics and our initial report of findings, which is usually done in the form of a PowerPoint file. So that takes time too. These graphics are no joke. You have to use either Excel or some schedule drawing tool, and they take a little bit of time. So that's what it did. It took us about 6 weeks to get there. You know, about 50 grand if you do the math, $200 an hour. So that's, you know, generally speaking, on a $2.2 million extension of time claim to do the analysis for 50 grand, you know, that's money well spent. But I'm telling you right now, we could do it in a day. What we do is we follow various approaches. I mean, if you've studied up on delay analysis, and I would say the AACE organization is probably the #1 organization that knows most about delay analysis. There's many different ways to do it, starting with looking at observational and getting into modeled. Explaining these a little bit, I think there's terminology that people use. There's the as planned versus as built, which is 3.1 over to the left here. That's when we just compare baseline logic with as-built data and understand, you know, statically what did the delays look like. We can break that up from, you know, the entire job to various periods throughout the job using contemporaneous data. But then we start getting into the contemporaneous updates and the modified reconstructed updates, this dynamic logic. This is where we're using every schedule that's out there. Contemporaneously, you can pick and choose, but use every schedule, don't touch them, analyze them, see what it tells you. And then once you start to find problems in those schedule files, for instance, there's missing logic, there's too many activities with like 90 days of duration that continue to hijack the critical path, things like that, you need to then run a modified reconstructed version. And this is really where consulting dollars go through the roof because you're having to manually go into schedule files and make changes, and it literally will double your cost for a consultant because you have to actually manually make decisions. And actually, when you start making those decisions, it's very hard to bring them back to light when trying to negotiate. And the whole reason most of us do delay analysis these days is to argue who caused the problem. Then there's other methodologies that we know of called the additive and subtractive. We see this all the time with, delays being put into fragnets and entered into the schedule, and then other ones that were already put in being deleted from it, and then determining whether or not that there was an impact, whether it's on the as planned or on the as built. Now, obviously, I can talk about this all day long, probably for a month long, and happy to do that if anybody wants to. But for purposes of today, we're going to just go ahead and jump into the program and walk you through it. Just to make sure everybody can see two pages here. On the right-hand side is the schedule analysis tool. On the left-hand side is this recommended practices. One of the things that I'll tell you right now is SmartPM has the ability to do every one of these types of analyses. We also have the ability in the program to reconstruct and model scenarios in minutes instead of days, if not weeks, that it takes to do it manually. We also do capture NOAA data, so as part of our analysis, we're always studying delays and identifying the activities that are delayed, but we're also capturing weather data to determine if the weather was excessive. One thing I'm going to tell you guys, which is very interesting, is there is a man outside my window cleaning it right now, and it just so happens the day that I'm doing this webinar, the guy who's cleaning windows has to be outside my window. So if you hear any weird noises of kicking and pounding on my window, it's not me. It's the guy cleaning my window. But I'm going to jump back over to this this analysis here. It's done. I'm going to go over to my second screen, and now you can see on our screen we have a bunch of schedules. This is our schedule listing. We show what our plan percent complete. We show there goes that guy cleaning the window, and our actual percent complete. If we keep going to the right, we now have our analysis. And what's really cool about this analysis is we have the ability to look at the quality of every schedule using the DCMA methodology. And in this program, we're able to gauge quality in terms of, a letter grade, like you're in grammar school. This particular schedule got a B minus. It eventually, got into the D plus range and got a few Fs towards the end of the job. So that starts to tell me a story that the schedule started average and it only got worse. If we go across the line here, we can also see, what kind of delay was happening in each period. Our program has now run a full Windows style analysis looking at every single update, and it's given a schedule quality grade given on DCMA. But on the far right here, we're also able to see compression. This is really where we start to study changes over time. Were there excessive changes happening, and what was the ultimate effect on compression of the schedule? And compression to me means how much more work are we trying to get done in the same amount of time that we originally planned. So if I'm to look at this 1026 update right here, we've got a C minus. We also have a schedule that's at 1.5 compression factor, meaning that we're trying to do 1.5 times as much work as we originally planned in the remaining duration of the job. So just looking at this, I'm starting to see a pattern of compression and changes resulting in schedules that are becoming, less quality, which is going to factor into some of the decisions that I make as I refine the data here. If I'm looking at quality right now, I'm looking at my most recent schedule. This is the as-built schedule, got an F, probably because a lot of logic was removed. But I can go back to any schedule early on, particularly the baseline, and I can start to see what did I get? Why did I get a C? And really what we look at is generally the usual suspects that any program looks at. We're looking at things like missing logic. We're looking at the types of relationships and determining if there's excessive amounts of start to starts, finish to finishes with lag. We're looking for things like high duration activities and the frequency of those. And all of that's rolling up into a report that gives us a grade. And then we're also able to see, areas where we're doing okay. For instance, there's no constraints in this schedule, and that's a good sign. There's a nice factor of relationships to activities, and that's a good sign as well. So we can do that for every single update rather quickly and really get to a place where we understand whether or not this analysis or the schedules that we're using as a basis is reasonable. As we also go through it, we now have a delay table. In each table, we can see, in each period, window style, whether or not, the end date shifted out. This right here between the baseline and the update, we see that the end date shifted out 8 days. We can also see if there was any delay, critical path delay or critical path recovery. Critical path recovery, meaning work was done out of sequence to recover any historical delay. And then that all translates into a net delay calculation. We can also see compression and changes to the end date via future changes to the schedule recovery. For instance, if the end date didn't move out as much as the delays that occurred, then that means some changes were made and may have resulted in compression. And we can also open up the actual window and see what delayed it. But for purposes of what I want to show you right now, we can also show you reports. I can show you a complete report of my schedule with delay incorporated, a delay table, and a version of changes that happened over time. This is what we call our pink report. So this analysis that was run on the last update, I can now see a version of my entire analysis with my historical critical path. I can see what delays happened to what areas over time. I can see which schedules were imported over time and where that critical path. And I can also start to see whether or not that there was compression happening and any potential concurrent delay issues happening in the period in orange here. And we try our best and actually do very well at highlighting the historical critical path, which is something no other program really does at all. So anyway, that's where we would go to see it holistically. We'd also have a table here. This is something that people can print out. I mean, these are the things, this is ultimately what we handed over to our client on behalf of the project when we did it manually. It was understanding all these bits and pieces and parts. Sorry. So I'm going to close out of this again and go back to our analysis, and I just want to show you a couple more things, including, the audit log. At each update, obviously, we have delays happening. We're calculating that. We understand what's delaying the job. We are able to see it and also see that there was recovery being built in, resulting in compression. And that's where we start to better understand what changes were made over time. And that, as we want to understand that, we need to see, what kinds of changes were made in time and which ones were critical and which ones were not. So if anybody's ever tried to do one of these modification analyses, programs out there like Claim Digger or Fuse, they allow you to see the changes, but what they don't tell you is, did it have a material effect on the critical path or not in that update? Was it geared to compress the schedule or not? And we actually show that by allowing you to see in each update, what were the activities that impacted the critical path? What were the changes that impacted the near critical path? For instance, you see right here, this elevator activity went from 90 to 30 days, and I'll show you that in a minute. So we have the ability, A, to look at quality, B, to see delay, C, to get an audit trail of changes. All of that rolls into our summary where we're starting to see a trend of quality, delay, recovery, variance, as well as our scheduled completion and compression being built in. So this summary table becomes very powerful to me, especially if I've taken a minute or two to go through the quality of the schedules and determine at which point do we believe that the schedule was no longer feasible. And right now, looking at this right now, I see that, I have done this Windows analysis. I do have my analytics, but I also see a red flag here that tells me that the schedule started getting to a point where there was probably bad data couldn't be used for analysis after that point, particularly because the schedule was too compressed and the quality which the schedule was built was getting to a range of a D+. So I'm going to have to do something about that. That's where we can start to create scenarios. But before I get into that, I'm going to do one more thing. I'm going to open up the program in a Gantt chart format. We have the ability to open these schedules via a CPM scheduling engine that's been built in. We have the ability to organize, sort, and filter these things so that we can look at specific activities if need be. For purposes of today, I'm going to look at it via WBS. I'm going to roll it on up so it's a little bit more clear, broken out by WBS item. And then I'm going to start looking at things like, anomalies in the data. For instance, I see this critical path starting out in, NTP or site prep stuff, getting into foundations and slab on grade. Actually, I'm going to open up my delay table as well so I can, kind of navigate this all at the same time. Well, at one point, I also see the critical path actually go right back into submittals and long lead items. And when I open that up and I want to better understand what was that item, I see that this elevator procurement activity that we talked about before getting shortened was actually on the critical path. So I want to determine right here, is this something that might actually need to be removed from the analysis, might actually be misleading? Is it something that I want to just take out of the analysis as a what if to see if the critical path actually goes back into structure? And I can do those sort of things. I can actually go find that activity. I can look at the audit log. I can see when a change was made to that activity, and it looks like on 8/26, that activity was shortened from 90 days to 30 days. And actually, if I look at this calendar, I can see that that's exactly when it stopped being critical. So if anybody here is a scheduler, you know that when something's critical and it stops being critical, then a logic change or a duration change was made. And we might want to decide that we want to reject that change, or we want to, make that change reflected in our earlier schedule. And that's really where we start getting into our modeling. So that's really how you would navigate this program. Again, you can open up the audit log. You can go see what decisions were being made and if activity durations were getting shortened that were ultimately 1-for-1 day, compressing the schedule. And then we can also get back into some refining of the analysis, and we do that via scenarios. One of the first scenarios that actually has already been built by my boy Billy was an as planned, as built. As you know, right here, we see our original schedules, and if we're going to look at the details, we see that every one of these schedules was utilized as a basis for analysis. Billy's gone ahead and created an as planned, as built version, and I just want to make sure that he did it correctly. So I'm going to look at those details, and I'm going to see that we've got our as planned being utilized, and then all the schedules in between are not being utilized, and we've got our as built being the basis for analysis. So what ends up happening is the logic contained in the as planned and the durations contained are being measured against the as built data and running the same analysis as if it's one giant window. And we're going to calculate delay based on that. So as I close this out and I want to actually open up the analysis and show you the difference between the two, because there is one, I'll open up my report. I'll go into my pink report and I'll show you the original. Just so you can see what it looked like originally with all the schedules and the schedules being updated, and I can show you the time frames for which they were updated. You see all these schedules being updated. Those are the periods, and all the data for those periods is being accepted. This is your contemporaneous static Windows analysis with no changes. All originals are saved. But when I want to do the as planned, as built version, I just got to open that back up in our program. I've got to tell it that I want to look at my as planned, as built. As you can see now, there's only two reports, the baseline and the update. I'm going to reopen that. I'm going to show it by level, which is our WBS structure. We can actually show activity codes too. But when we do this, you'll see that it's slightly different. We've got a little bit more ironed out version of that critical path. Starting in foundations, looks like there was some recovery made in superstructure, back into rough-ins and site finishes again, just like we saw in a little bit more detail. So we need to determine which one is accurate. And again, we see that elevator showing up here at the top here, so we want to maybe get that removed. So I'm going to go ahead and actually do that. I've showed you that we can do various scenarios, and we do create a scenario if you wanted to do an as planned, as built, just like Billy did. And I'm going to do actually a hybrid version because I like the fact that the first half of the schedule seemed reasonable, but I don't like the fact that the last bunch of schedules seem a little bit too compressed. So what I'm going to do is select the first half of schedules through that 10/26 date. Actually, I'm not going to do 10/26. I'm going to do 10/2 because it went to a C-. And then I'm just going to grab the as-built data from that point on. So now we have sort of a hybrid of your Windows analysis to the point in which you actually feel comfortable with the schedules. And then we get into another version. I'm going to write hybrid real quick. Got Billy here helping me out, telling me what I'm doing wrong. Now I'm going to say next, and it's going to tell me these are the schedules I want to use. And I'm going to just say finish. And what's going to happen is a new scenario is going to be created. I'm going to refresh my screen. And you see that we've got this as planned, as built. The other thing that we need to talk about here as that runs is corrections. You know, we have various corrections and the ability to do corrections. I'll just open it up. You create rules. And I'm going to actually go through this real quick and show you that we are going to go back and we are going to reject that elevator change as well, because I don't think, or we're going to revert an elevator change that happened on 8/26, if everybody remembers. Sorry, I'm going to cancel out of this. We're going to revert a change to that elevator. If we saw before that one elevator activity went from 90 days to 30 days, and it happened right as the activity was becoming critical, which guides me to test whether or not that should have been the case the entire time. So what we would do is we would find that change on that 8/26 schedule. We would say, all right, find me that change. We recall it was a near critical change, and we see it right here. This elevator procurement activity is now getting shortened down to from 93 to 30 days. So I want to actually make that reflected in the baseline. I'm going to call it out. I'm going to say, make that reflected in the baseline. It happened on 8/26. We want it reflected in our 119 and going forward. We're going to name it revert elevator change. We're going to save that as a rule. So if anybody's ever tried to go back to a baseline schedule and all the subsequent updates and make one little change, and 2 hours later you had to figure out that you made a mistake somewhere, well, this fixes all of that. I'm going to go ahead. I have that elevator change. I'm going to run the same analysis. I'm going to create a scenario. I'm going to give it a name. We're going to call it Windows with elevator change. I'm actually going to do the same thing I did last time. I'm only going to take the first bunch of schedules up through that 10/2 date, because I believe that that's most probably accurate. And I'm going to go down to the as-built. And then when this goes to the next screen, it's going to show me that rule I just created, and I'm going to get to pick this rule right there. And now that rule is going to be incorporated, and it's going to become another scenario. And as you can see, when I rerun this, I have a new scenario. So just to show you guys what I've done, I've now got 4 delay analyses running in this hour. So I lied about the 1 delay analysis. I've now got 4 running, and they're all running in the cloud. And as that happens, we're actually going to go back to our screen here, and we're going to talk a little bit about delay again. What I want to talk to you about is this added, reconstructed, modified approach. I've spent a lot of time doing this type of analysis, and I've gotten actually very frustrated. I've gotten very frustrated that the schedules that we rely on for purposes of this analysis are often very, questionable. And the questions that I have are usually different than the questions that another analyst has, which causes arguments. When you have 2 consultants butting heads about their opinions of things, you don't really get too far. Actually, you get a nice seat in court. That's what happens. So we're going to change all that. We have 4 ways to change things in this schedule. As I talked about revert, we are allowed to take any change that happened down the road and make it reflected in any schedule. It can happen sooner, it can be in the baseline, it can happen later, it can happen the month before, the month after, 3 months before, but you make those changes, and you can do it for any change. Of thousands of changes, you can do it for 1 change, you can do it for 10 changes. However you decide, you can test those things, you can put it in. For instance, if somebody came along and added logic amongst a bunch of activities and you wanted that reflected in the baseline, you can call those 5 activities out and revert them to the baseline like we did with the elevator. We also have the ability to reject logic or to reject changes. So going from one update to the next, you can reject critical changes, near critical changes, all changes. When you remove a schedule from the analysis, you're essentially saying, I'm not accepting any of these changes, but I will accept the as-built data. The other thing that we can do, which is really cool here, is the bulk change. I really love this one because we can actually break the schedule up to bits and pieces. We can remove, things like procurement activities or entire phases. You can look at construction only. If schedules have multiple milestones with LDs associated with them, you can pick and choose which milestones you want to be focused on, and it will do a backwards traverse, and only grab the activities related to that milestone and create its own analysis. So now we can be not just analyzing the job, but we can be analyzing specific points in time or specific milestones and everything that delayed that, which we all know could be different than the true critical path of the job. The other thing that we can do with that same change is analyze subs. For every sub, we can go to their last activity, create that as the point to be analyzing delay, and now we can be able to see, every sub's story that may be separate from the overall holistic job, like what impacted a sub. And then there's the ability to do what I call as a one-off change. And that's where we're able to go back into the schedule at any given point in time and make some decisions of our own. For instance, we can remove a logic tie, or what I see all the time is a 20-story building going up, and there not being any logic ties in the drywall, so the critical path ends up looking like a hockey stick going up the concrete and then sticking on the top floor, which isn't really true. We know that the critical path is going to go through the trade, so you need to have that crew logic. And I'll be honest with you, probably about 75% of the schedules that we look at probably are missing, a lot of crew logic. I just know that from our own quality assessments of, some of the schedules we've seen over the year. So that's really what we can do with that. And at the same time, all as-built data can be modified in our system. Start dates, finish dates, progress over time, all of that can be brought down to the daily level, and it can be understood. I'm going to jump right back into this analysis. It's ready to go, and we got about 20 minutes left, so I believe we've done 4 delay analysis in 41 minutes, which is a good thing. I'm going to go pull this up, and as you can see now, I'm going to refresh this screen, and I can see that now all my analyses have metrics related to delays. We just now need to go study what they are. I'm going to go open this up. I'm going to go look at my windows with my elevator change. I'm going to make sure that my report now shows me that that elevator issue was taken off of the critical path, and we'll just check that out. So as we go down the line, yep, now we see that that elevator issue's off the critical path, and now the critical path has gone back into foundation. So by reverting that change, it changes everything. So this is a scenario that we can now discuss with the other side if we need to, or include it as part of our analysis when requesting time and money. So all of that stuff has been done rather quickly. The other things that we can do is look at weather. And one of the really cool things that we can do, and I'm just going to go ahead and show you, is when we want to start getting really, really detailed here and we want to look at the windows for what they are, we can go back into our Gantt chart. We can then go open up a specific window. For purposes of right now, I think I will open up, I'm going to go ahead and open up this 631. As you can see that there's some delays, and then there's also some recovery, and I want to understand what that is, because I see 22 days of delay, 13 days of actual realized recovery due to out of sequence work. And now I can then understand, well, what happened in that period. This is where we start drilling down to the window, the actual window, and looking at the activities. So now I can go back up into that, and I can see we have our foundations activities happening. Looks like this anchor bolts and templates activity started out of sequence. It probably was going to be the precursor to pouring and backfill, but instead it got done sooner. Simultaneously, we see that critical path in red. If you look really closely, you can see there's red, that's critical. There's X's, those are delays. There's green, that's recovery. And then critical path continues on into our foreman slab edges, but we see that there's delays there too, and it looks like, lo and behold, they've gone ahead and started building out slab on grade without doing that, and all in all, we start to get some recovery in here. So understanding not only what was delaying the job, but also in a given window period, what was the out of sequence work and how did that translate into recovery is a thing that is very hard to figure out. Most analyses don't even include that, but now we're able to do that using our methodologies that we've built into this tool. We're at about 12:45. At this point in time, I'm actually going to be able to answer some questions because this thing went a little bit quicker than I thought it would. So I'm going to pop some questions open, and I'm going to answer them. Asked is, can it be organized using activity codes? Absolutely. Let's just go ahead and show you that. I'm going to move this thing here. When I want to look at that report and I want to see it organized using my activity codes, I'm going to open that report. I'm going to go find the activity codes. I'm going to sort it by bid package, which is essentially the trades. And I'm going to print that thing out. And you can pick and choose various activity codes. You can go multiple levels if you want. But now if I'm looking at this from a different perspective, I see that each one of my trades is now analyzed and sorted based on delay. And it looks like this trade right here, bid package 04, which is our concrete guy and our site guy, is looking like the issue that we need to really look closely into. But that's how that works. You can pick and choose, various ways to organize it. And I'll be honest with you, that saves a lot of time because I can't tell you how many days I've gotten sent back from a client and had to spend like 4 days redoing my graphics and how much fun that is. Now you just got to click a button. I'm going to jump back into our slideshow and answer a couple more questions here. Was out of sequence work on the schedule you use? Was out of sequence worked on the schedule you use? Yes, as you can see. Has a question about weather. Good question. I'm just going to open it up for you. Based on the location that we pulled, it's going to give us weathers for every single day of the job. It's going to tell us how much rain, what the temperatures were. This is our phase 1 weather analyzer. The next one that's coming out probably in about a month is going to take your 10 and 30-year averages, tell you by month how many expected rain days you should have built into your schedule, and then monitor based on whatever conditions that you put in there, how much rain or what temperature it is, how many actually exceeded or were less than what was planned. But yeah, right now we merely pull it in from NOAA. The next phase is to start running calculations consistent on how we typically do analyze weather. I'm going to shift gears back because I think we are now getting to a point where I can wrap up. I'm going to go back to my main screen and just talk a little bit more about this tool and what it's been used for. One of the first things that's powerful about this tool is that I've been doing delay analysis for 20 years. I've worked with many consultants who've been doing delay analysis for the same amount of time. And just the amount of stuff that you can do in days mirrors the amount of stuff that used to take us months and sometimes a year. This is so powerful. The other thing that happened to me, and I'm a little sad to say it, but I'm just going to go ahead and say it, is I competed against this product. When we designed this thing and we built this thing, I needed to test this thing. So the only way to test is to go off and do my own analysis and then compare it to what the program says. What I've realized, which is very unfortunate for me, is that I was wrong. A lot of my analyses were flat out wrong. The way that I looked at it with my, broad-based assumptions and my calculations with Excel and determining what I believe to be critical at different points in time and when those shifts really actually happened, I was wrong a lot of times, which told me a lot. It told me that I spent, and other consultants as well, we were all, outdone by this computer. And it makes sense because every analysis we're doing, tens of thousands, if not hundreds of thousands of calculations. We're running an analysis every single day of the job, which is what AACE says you should do, but no one ever has any time. The program now allows us to have time. And what that does for us is allows us to use this proactively. The other thing that's really cool that happened a lot was when, as a scheduling analyst, when the data wasn't very good, we'd go off to our corners and we would, make some assumptions and make some changes and then come up with an analysis. But the hard part was explaining that, because the other person who's doing the same thing, on the other side of the contract has their own assumptions that they're making. And when you come into that room to discuss and to negotiate, nobody can really articulate their assumptions very well, and nobody can actually trust that that was the case. And that's what happens when you remove X, Y, and Z, or you add logic, or you shorten a duration. It's all subjective, and it's all believed to be subjective. Our program makes it very objective and very transparent and very visible. We've had a lot of discussions with our tool to get to settlement, and I'll tell you what, it's never left the trailer. Most of the time we're in some lawyer's office, but now we don't even leave the trailer, because the power of this tool and the objectivity and the transparency changes everything. The other stuff that we have going on with this tool, we have customers using it proactively and reactively. I say proactive is forward-looking, used at every month, studying quality, studying compression, studying changes, and studying delay, and predicting a future end date. We can do that with our tool. So it begins to help, minimize the time necessary to go through each schedule, and it helps maximize the number of things that one can do with the time that they have. Right now, my opinion is, when studying schedules, people don't have enough time. They don't have enough. Surely they have enough time, especially with some of the tools out there, to maybe look at logic, maybe look at durations, but nobody really has the time to run delay analysis on everything, and nor do they want to go hire a guy like me. It's costly to hire a delay consultant, and it takes a lot of time. Our program changes that. Right now, we're charging $300 per month per project to have all of these things, which is just dwarfs the cost of a consultant to do even one of those things. The other thing that people use our program for is change management, testing out, whether or not a fragnet of changes actually impacted the job, instead of just coming in with a long fragnet that is, turns everything red all of a sudden. We're actually going to go put in the as-built data after it's done, throw it into the activities it was tied to, run the analysis, and see if it ever was critical, and if so, how far it critically delayed the job, using actual data. The other thing that we're looking at here constantly is compression, feasibility, and that all feeds into our predictive analytics engine. I'm actually going to pull this back over so you can see it. Right now, in our program, we have the ability at any point in time to be looking at, what was our delay, what was our quality, what was our recovery, what was our end date variance, and at each update, we're able to see, at this point in time, is the schedule even feasible? How compressed is it? What's the current scheduled completion? What's the forecasted completion? This schedule actually has been saying, if you run it out, that this project was going to get done in September, since 9 months before it was done in September. And on this last update, it's still saying it's getting done in September, but the baseline said it was supposed to be done in March. So we have that ability. We have built in those predictive algorithms that we use as consultants. Other things that we obviously do are delay analysis. We have the ability to support entitlement, because you can always build into each schedule. We have the ability to tie documents to each activity and create a document trail. For instance, if I want to put a document and associate it to why these foundations were delayed, it could have been an RFI, it could have been not enough manpower. I can go find that paper trail, and I can associate it to the activities for discussion purposes, of course. And finally, here we have the ability to do, delay analysis in any one of those things. And finally, one of the things that I pride this tool on, and it's going to continue to get better, is this tool is simple enough for a person who's not spent their entire career doing what I've done. For somebody who's never done a delay analysis in their life, we have a quick training program that gets people up to speed on getting answers without actually having to hire the consultant. But that all being said, I'm not going to say that hiring a consultant's not a good thing. Consultants have a lot of experience, but what we also do is we make it so robust for a consultant to utilize, and it adds so much more power to the process by being able to look at those scenarios, test data, do what ifs, and ultimately look at the analysis in any one of those 4 capacities: as planned, as built, windows, time impact, collapsed as built, any one of those lights, and see the differences of what the data is telling us, and then determine, what do we believe to be the case, all on top of that being able to modify things that we believe to be bad data. One of the other things I'll say here, and then I'll probably hop off, is that our customers are saving lots and lots of money, on any sort of time impact request. Really quickly, we're able to assess it and get the settlement in the trailer. As I said, we've saved customers, $500, $700, $1.2 million on these requests. At the same time, we come in, we do managed service here, but our price point is about 1/6 the cost of the consultant. We've done a lot of these analyses, and we've actually gone head to head with consultants, and we've actually come in at 1/6 of the price and done twice as much analysis. So you do the math there. But more importantly, and really the whole reason we've gone ahead and built this tool is because this construction industry has way too many people arguing after the fact, in my opinion. I was a forensic analyst, and I got sick of it. I didn't want to, I knew that we don't need to be waiting until the end of a job to be arguing out things that happen in the beginning. What we need to be doing is better understanding them. I also know that hiring an expert to do that takes too much time, and no one likes to spend $10,000 a month to do it early on in a job. So what's the solution? Technology. And that's what we've built here. So I hope everybody has enjoyed this. I hope that this was a very good presentation that gave you a good grasp of, all the work that we've done over the last 3 years building this thing out. I will go out on a limb and say that this is probably the most powerful tool that I've seen in construction when it comes to analytics. And I also will tell you that we have quite an extensive roadmap to make it even better. We're starting to touch into machine learning. We're starting to touch into AI. We're also letting the program fix schedules without the person having to fix problems like missing logic or too many high durations. Giving recommendations of changes that should be rejected or logic that should be added. We're getting into that. And then we're also getting into throwing cost analytics on top of it all. I personally believe that the schedule-centric model is the way to go. We run this schedule-centric model like you've just seen, but throwing cost on top of that's going to be, throwing gas on a fire. So anyway, I appreciate everybody coming today. Feel free to reach out to us via email if you'd like to talk a little bit more about the tool, and maybe if you have an analysis that needs to be done or you're interested in trying it out, by all means, give us a call.